Okay, so I'm here with my latest experiment I'm starting with. What this is an aquaponics unit. It's actually, well, this is an aeroponics unit, but I'm going to convert it to an aquaponics unit by submerging it in my aquaponics pond. I'm going to have a water exchange between my aquaponics pond and this. I'm also going to have some goldfish in here. The water is going to be pre-filtered out of the pond and then put into here with a toilet flow valve. That's an eventuality, but what aeroponics is if you look down and in there, you can see those sprayers. Good thing I have a waterproof phone, but those sprayers spray the net pots down there, which has the grow medium in it, and that just runs all the time, and it keeps nutrient-rich solution or water covering your roots, and it grows the plants without the aid of soil. It's kind of like hydroponics, but instead of a slow drip or anything like that, this is an active spray. Now the pump uses 24 watts, and my summertime plan, I'm actually going to convert the overwinter greenhouse, which is my growing platform. That's going to be all solar, so I'll have to account this 24 watts plus the other 54 watts. So I'm going to need at least 200 watts of panels. But that's going to come later. And what I'm doing, this is an actual experiment. This pot right here, I'm going to have the traditional grow rocks. There's already some in there. I'm sure you've seen them before. They're those things. They're made out of clay. Pretty cool. You can see the water spraying up. But those are made of clay, and what they do is they're porous and they absorb water and allow the roots to grow in. As far as these other three, two of them I'm going to run this stuff right here as a medium. It's called beach glass. I'm sure you've seen it before. This is just broken glass that is washed in the ocean, in the currents and the waves of the ocean, until it becomes smooth. But it happens to pick up water. I noticed it gets like a cloudy. It's very porous on the outside. It doesn't appear that way, but it is. It holds water. I've noticed, because I use it as a false drainage material for my forever gardens, and I noticed the water holding effect during that. It actually wicks the water up. So I'm going to attempt it. Two of these are going to have that in it, and the third actually is going to be this stuff right here, or the final one I should say. And what this is 3D. This is all 3D printed. And these are rounds for a paintball gun. They're rifled. And I have a whole lot of them. But what I did is I made a couple error batches that I had a setting mistake, and they're very porous. They don't look smooth like those. They're porous. They're all full of holes. I really actually don't know how I did it, but two batches came out like that. And those other things you see there are bullets that I was 3D printing and testing. Those actually work fantastic. That's for another video. But I'm going to fill the pot with that and test that as a medium versus the traditional. And one last one, I left this one out. The final one here, I'm going to use this Pro Carb Z, and what that is it's carbon and zeolite. It's normally used in fish aquariums as a filtering material. I'm going to use it as a growing substrate, test it out versus the traditional, the beach glass, and the traditional Grow Rocks beach glass, 3D printed material, and zeolite-carbon. So it's a test versus the four. And what I'm going to use is these plants right here. I've got 4 uniform ones. If you look, what those are French thyme. And I'm going to use those as a test bed, because that's for a whole nother business that I'm going to attempt to start, and it's a project and a business all in one. But I'm going to grow a whole lot of thyme this year in my garden, and I've got an extracting machine for getting oils out, and I'm going to use that extraction machine to produce thyme oil, which is a natural It's used in industrial purposes as a disinfectant. It's also used as a cleaner in the mold industry, and my idea is to make a natural organic cleaner and do some testing, see if I can make a product out of it. If not, I tried. I'm pretty sure that I'm on the right track with that. I've done a lot of research. One final thing, this thing is called a misto. It's a product made for, actually I think it's made for like cooking oils and such, but see the top goes down, and what it is, it's a refillable, reusable spray bottle. That's the piston that pumps it up with air. You just put that on and you pump it, but as you can see, it works very well for watering plants. You can create a pretty high pressure mist and meter it out really well with this, amazingly well. You can apply just small amounts of water. Probably with my high-end Forever Gardens, I'm going to include one of those as a accessory, or maybe even include them in the high ends, just because it's so convenient for watering and cleaning the sides. But I got one in my cupboard for oil as well. Works really good for spraying oil on pans, and it's reusable. It's easy to clean. But anyway, that concludes this portion of the video. Probably add on another one once I get the plants planted and get it placed into the overwinter greenhouse. So I just noticed the most interesting thing. This is that carbon zeolite mixture that I'm using as a grow medium. If you listen, it sounds like Rice Krispie treats on steroids. I just added water to rinse the stuff and get all the carbon dust out. And listen carefully. What that must be caused by is carbon's highly porous. If you look it up, it's got just millions of pores per square millimeter of volume, billions even. It's one of the most porous substances known. Now that I'm looking really close, I can actually see water moving out of the carbon. Not sure if you can see it, but yeah, it's pretty interesting. As you can clearly see, I have this pretty good sized pile of discards of mostly PLA with a little bit of nylon, just a tiniest bit, a couple nylon turbines that failed, and then everything else is PLA. But this I'm going to put into the net pot. I'm going to cut all this stuff up in bite-sized pieces, put it into the net pot, and finish up with those around the little thyme plant. I'll change the experiment up a little bit. This is the beach glass with one in it. There's your carbon zeolite mixture. Another glass one. I did 2 glasses for balance. The grow rocks were extremely light, and I'm finding that this plastic side's going to be too light, and it didn't cut up quite enough. Well, the stuff shrunk up when I cut up the 3D printing discards that are at the bottom of this pot. And I got the misprinted paintball rounds up above, but I'm going to put a layer of glass over this for weight to press down on and squish the discards down at the bottom a little bit, because there's a lot of open air and it needs a little bit of extra weight. So I'm going to put brown beach glass on the top of this one. So next time you see it, you'll just know that the brown glass one has the pure 3D printed substrate. There's no soil. I actually transplanted these, which is taking a risk, because when you don't have the soil medium there, you can do some damage to the roots, and I'm sure I did. So hopefully these survive the transplant shock. I'll do my best to ease them along, spray them, keep them indoors for a couple days, and put them out in the overwinter greenhouse. Okay, just finished the first stage of the aeroponic slash aquaponic aquaculture experiment. I'm also doing an experiment on various substrates here. Here we've got clear beach glass, or sea glass as it's known, which is glass that's been rounded out by the waves in the ocean, recycled glass. In this one we have a zeolite and carbon mixture that's often used in fish aquariums for keeping the water clean. This stuff right here, this brand, ProCarb Z, this is good stuff. You use it for a lot of different things. I balanced it out by putting the clear beach glass on this side as well. You see I transplanted all the same size tine plants. Now this is brown beach glass, but it's only about a ½ inch layer covering up 3D printed materials that were discards. So I'm doing a test to see if this thing will basically grow in 100% PLA 3D printed discard material. It's just under that layer, but so yeah, that's another experiment. And I'm just going to test all these. Now I've ran this with soil, and I've grown thyme many times, so I know how fast it grows in soil, and I also know how it grows in clay hydroponic rocks. So I really don't need to test those because I know the growth rates, but I don't know the growth rates in sea glass, or even if it will grow. So this will be interesting. Anyway, until next time.